Hi, welcome back. In this lecture, I will cover degrees of freedom. So let's start. What are degrees of freedom? Number of independent movements that an object can perform are known as degrees of freedom. Look at this figure over here. It has three axes, X, Y, and Z. Any object in this 3D space can move along X, Y, and Z directions. So, these three movements result in 3 degrees of freedom. In addition, the object can rotate about x-axis, y-axis and z-axis, so 3 more degrees of freedom. Therefore, a rigid body in free 3D space has 6 degrees of freedom, 3 translations and 3 rotations, which means 6 independent variables are required to specify the location of an object in 3D space. The number of degrees of freedom is equal to the number of independent variables required to specify the location of an object in 3D space. Now, talking about 2D space, only 3 degrees of freedom are required. Look at this figure. One movement in x direction, second in y direction, and third is rotation about the z axis. So, 3 degrees of freedom are required. For a manipulator in 3D space, 3 degrees of freedom can be less or greater than 6, depending upon the application. Let us try to understand by an example. A robotic arm is shown over here, in which link 1 can rotate about base B, which is fixed to the ground, so this contributes 1 degree of freedom, and link 2 can rotate with respect to the link 1, so this again contributes 1 degree of freedom. So here 2 degrees of freedom are required. Okay, now a point to remember is that in an open kinematic chain with one end connected to the ground and farther end of last link free, the number of degrees of freedom is equal to the number of joints or number of links. Look at the previous example. This arm is a kinematic chain with one end fixed and other end free, has 2 degrees of freedom, and number of joints are also equal to 2. One joint is between base and link 1 and second joint is between link 1 and link 2. Number of links are 2, so remember that for such a kinematic chain, number of links or number of joints is equal to the degrees of freedom. Moving further, an important term in robotics is joint link variable. It is an independent variable that defines the motion of a link at a joint. So, number of joint link variable required to completely specify the location of an end effector in a manipulator is equal to the degrees of freedom in a manipulator. Simple and easy? Okay, moving further. In a manipulator, 3 degrees of freedom are for arm, that is for positioning the end effector, and 3 degrees of freedom are for the wrist, that is orienting the end effector. 3 degrees of freedom are for positioning of the end effector and 3 for orienting the end effector. A manipulator that requires a 6 degree of freedom, 3 for positioning and 3 for orienting, is called the spatial manipulator. But the number of degrees of freedom can be more or less than 6, depending upon the application. In a manipulator where degrees of freedom are less than 6, the movements are restricted by constraints. And where degrees of freedom are more than 6, such manipulators are known as redundant. Redundancy increases performance by adding to its dexterity. Dexterity means capability to reach obstructed subspaces. The capability to reach the difficult to reach areas is the dexterity. A robotic arm is used for various important applications. So, there are some characteristic requirements of a robotic arm. Number 1, length should be long enough to provide maximum reach in space. Number 2, design should be mechanically robust as the arm has to carry weight of wrist, end effector and workpiece or tool. So that was all for this lecture. See you in the next lecture.